Okay, what forces are acting on you right now? And are any of them stronger than gravity? And so depending on what you're doing, there are all kinds of things that could be acting on you. If you're sitting down, which probably most of you are, you've got a chair pushing up. We call that the support force, the normal force, pushing up on you. Gravity pulling down on you would be two big ones. But is there anything else? And the answer is there is, or there are. In fact, it is stronger than gravity. You just don't feel it. Those forces are electrical forces. Electrical forces are billions of times larger than gravity, or billions of times stronger than gravity. And that's what this diagram is showing. There's a little picture showing us that the gravitational force is actually very small compared to electrical forces. Now, the reason we don't feel them is because they actually cancel each other out. So some electrical forces are going to attract objects. Other electrical forces are going to repel objects. So when we combine those repelling forces and those attracting forces, they're going to produce a net force of 0. So the reason you don't feel electrical forces pulling on you the same way that gravity does is because it's like a big tug of war with two teams pulling equally in opposite directions. See, those forces cancel each other out, and you feel no net force. Key thing to remember when we're talking about electrical forces, we mentioned on the previous slide that they can be attractive forces or they can be repelling forces. So the key to remember here is that this all comes from atomic particles. And you learned about atomic particles in chemistry or physical science. We talked about the protons, the neutrons, the electrons. And you probably remember that opposite charges are going to attract. So in this middle image, we have a positive charge and a negative charge that are moving towards each other. They are attracting. So the negative charge pulls on the positive positive charge pulls on the negative charge. They're pulled towards each other. So opposite charges are going to attract. Like charges are going to repel. And it doesn't matter if it's two positives or two negatives. Anytime they have the same charge, they're going to repel each other. So in the left picture, with our two green positive charges, you can see they're pushing each other away. The one on the left pushes the right one away. The one on the right pushes the left one away. So they're pushing each other in opposite directions. The same is true in the right, the picture on the right side. Two red negative charges, again, like charges, so pushing each other away. So quick review if you don't remember those particles. So remember, protons are positive and they're found in the nucleus. Electrons are negative and they are found outside the nucleus. They're found in an area called the electron cloud or the orbitals. And they're very different in size. Okay, electrons are thousands of times smaller than protons, but they pack a lot of punch. Okay, they've got the same amount of charge, just with an opposite sign. Okay, so as much positive charge that a proton has, the electron has the same amount of negative charge, just in a much smaller amount of mass. And then there are the neutrons, and the neutrons really aren't going to be very important for this chapter because, well, they don't have a charge. We say that they are neutral. And they're located in the nucleus with the protons, but in terms of electric charges, electrical forces, they don't have them. So if we look at a helium atom, Okay, so this diagram shows a helium atom. We've got in the nucleus is the center of the atom. Nucleus consists of the protons and the neutrons. So we can see that there are two protons, which are colored green and have positive signs, plus signs, positive protons. We've got the two blue neutrons also in the nucleus with a neutral charge, so no charge indicated there. And then on the outside, we've got these electrons with their negative charges. And remember, positives and negatives are going to attract. So these electrons are held in the electrons are held in the atom by that attraction to the nucleus. Okay? It's kind of like the planets being attracted to the sun's gravity keeps them in orbit around the sun. The electrical force between those opposite charges keeps the electrons in the atom.